post call to show that it's all working end to end. So this is what we will try to cover today. So have your code ready and pull it up before we walk through. And I'm hoping all of you will walk through along with me while you're doing the code, because that is the best way you learn. I mean, in case there is some environment issue, you can stop me and we can try to fix it, because there are not too many people in the class. So I'm okay to be interrupted. Okay. Should we get started? So I just let me know if all of you have downloaded the code and got up to the point where you're able to do an mkdocs serve. And once you reach this page in your local host.
Done. Thank you.
Okay. Anybody who has not succeeded so far? I mean, I'll just take names. George, Aditya. I'm seeing some names in the Zoom, but I'm sure there are more in the classroom. Everyone reached that stage? Can I proceed? Okay. George has given a thumbs up. Maybe I'll just wait for Aditya. Aditya, are you done? I think because Asif is on mute, I'm not able to hear. I don't know. Maybe he's done. Asif, you're on mute. I am not able to hear you.
Sorry. Did you hear Aditya?
No, I couldn't hear.
That's strange. You should have been.
No, I think you were on mute, right?
Oh, that's right. Because I was on mute. I apologize. Yeah, Aditya like to say.
Can you hear me now, Chandran?
Yes, now I can hear.
Okay. I was saying that I got an error in MLOps, so I think it's because of the real lesson one directory is different this time.
Okay. That is because I didn't have that issue though. I'm wondering why. Did you replace? I mean, did I said you can.
Hamad walked over. Is going to help Aditya.
Okay.
It is supposed to be in SVLON directory, but I think this one is under real apps now.
So what you can do if you replace, I mean, as I mentioned, right? If you can get rid of the Ray lesson one, because I have moved it under the Ray labs. That you, I don't know if you have already done that. You can get rid of Ray lesson one, which was outside. I moved it under Ray lesson one here. And if you replace the docs, I think it should come through, because the docs I have already updated with the latest. Have you done both? Okay.
Yes.
Yeah,
you've done both. Okay.
Done.
Okay, great. Okay, so let's get started. This lab should not take too long because there are two parts to this lab actually today. One is using the model getting saved in a file path. And the second part of the lab, we are going to repeat the same thing where we will use MLflow. If you remember, we did MLflow a couple of weeks back. So what we will do is we will use the MLflow's model registry to save the model that is getting created through Ray, and finally serve it by picking the model from MLflow. So we will try to do both in the remaining part of the time today. Okay, so what are we going to cover today? We will use the Ray data set, which is basically a construct within Ray data. So that will be used to bring in the data. So we will ingest the data from the CSV format into this Ray data set. And we will use the train test split, which is available natively within Ray dataset, to split this dataset. And again, Ray dataset has pre-processing features where similar to what other scikit-learn and all that offer, it is Ray dataset offers. So we will use those constructs to do the feature transformations, which we earlier did with scikit-learn. Instead, we will use the Ray dataset. And finally, we will use the Ray tune feature to do the hyperparameter tuning. Okay, so these are what we will cover as part of the main, the flow in raymain.py. And once we are done with it, we would, the best model would have got saved to a particular file path. And for this, you need to make sure that in your LLM ops config, if you see this in your folder, the usual configuration file where you update all your config parameters. This is one which you should update to your a path in your local file system where you have access. So you update this to your and this will be where the models will get saved. Okay, so that is the reason why we need that path to be defined. Okay. So once you have done this part, we can walk through the code. First, I will walk through the code and then we will run it. Okay. So let's, have you made this update? Created a directory where you can save your results, and you can let me know if you have done this part.
Yeah, guys, please do provide feedback to Chanda as you keep doing it, so he knows.
Okay, so I'm assuming that part is done. So here, the Ray main, which is what we are going to run, I will not run it immediately. I will first walk through the code so that you have an idea of what we are doing. And once we understand the different parts of the code, then we will run it, because running takes hardly any time. So I want to first explain the code. So what are we doing here? The flow is, we will do an ingestion. The ingestion, if you go into the function, I will go into it presently. It actually brings in the data and also splits it into three parts: the train, validation, and test. It is actually doing a split. And then we are doing a pre-process, and pre-process happens only on the training data set first. So the is-train is true is passed here. I will walk through that also.
And could you increase your font size? On the screen,
okay.
It's
just a
up.
minute. Let me do that.
Okay.
Sorry?
Just hit Control plus.
Yeah, I'll do that. Is it better now?
Yeah.
Okay. So the next, after the ingestion, the next part is doing a pre-process with an is-train equal to true. And this will end up freezing the pre-processing, it will fit the pre-processing training. And we will use the same preprocessor subsequently for the validation and train. That is why we have this different flags here. I will show you what I mean by that when we go into it. Okay, now after we have done all that, we have processed data sets. And this is where we pass into the random forest, which internally does a hyperparameter tuning and also saves it into the Ray results folder. Okay, so this is the flow is very simple. Now let us walk through each of the code so you understand what are the specific array data features. So this is something which you have already seen when Asif covered. We are doing array data read CSV. We are taking this CSV, so it is creating a array data set out of it. And here we are using the data set comes with a train test split. So just like you have in scikit-learn, you have train test split, you have similarly in array data set has it. And here we are dividing it into a train and temp. I mean, finally, our goal is to divide it into 3 data sets. So this is what we are doing in this, very simple. So that is the ingest part. Okay. Then we go to the preprocess. What does the preprocess do? Note that we have a flag equal to true here. So when it is true, we are also doing a fit. We are having a preprocessor which is defined here. The preprocessor is a custom preprocessor which is again defined in the array data. So it just like scikit-learn has abilities to do a processing in a pipeline. Here also we have the similar kind of custom preprocessor, which here we have told what are the different columns, what we want them to get modified by. So let me explain a little bit the code. So if you see what is happening is this custom preprocessor is defined here. It is inheriting from the preprocessor. So this preprocessor is what comes from the array data. So we are going to inherit from the custom preprocessor, and we are going to specify what is the fit going to do here, what is the transform going to do here. So the fit is basically the training part of it, and the transformation is what is being done once we have trained it on the trained data set. So what happens is when a data set is coming for inference or validation, we should not be doing a fit once again. We should just directly follow the transform. So this is the normal practice in whenever we do a pre-processing, we fit on the training data, but we transform on both the training as well as the validation and test data. So that is why we have this separate fit and transforms. So what are these doing? If you see, we are doing a log transform of a few columns, and we are doing one hot encoding of one particular column. So that is mentioned here, which column we are doing one hot encoding of, and which columns we are doing log transform of. And one more thing is in this particular case, though we have the scale option, right now I am not using the scale option anywhere because log transform ends up working well enough for this particular case. I didn't use the scale transform. So that is just a minor point. So in fact, I have mentioned here currently left unimplemented for this case. But in a more generic case, you may want to use scaling also to do a standard scaling. And very similar, instead of doing a log transform, you would do a scale. So these functions are all defined in this code here. You can have a look. It is a simple function which is just doing a logarithm of each value. So this is what the pre-processing does. And as I said, it is having it takes a flag of is train, which could be true or false. And when it is true, we are making sure that we are fitting it. And later on, if is train is false, we would skip this part and directly do the transform. So let me know if any of this is not clear. I can go over in a little bit more detail.
Oh, yeah. Hey, yeah. Hamad has a question. 1 second.
Yeah.
What is joblib? Is it queue memory?
Sorry, can you repeat? I couldn't hear it clearly.
What is joblib?
Oh, joblib. This is basically to save the preprocessor. Also, it is a way to save it in a local file system. So these are ways to save the model that has been trained into a local file system so that later on we can pick it up if required. But in this case, I mean, we are not using it right now because if you notice, the preprocessor has already been defined and then we are using it later. But the reason for saving it is, let us say we are later on doing an inference. If we want to do an inference, we want to make sure that the inference is not going to go through this particular flow of coming from the main, right? So the inference will need to have the place where the preprocessor is saved. So that is why I have saved it in a file path, so that in a real-time service, in fact, we will see it when you go to the ray serve, no, which I will walk through subsequently. The ray serve will actually use the inference processor, which has been saved in the local file path. Did I explain or?
Yeah. So by the way, joblib, as Chandra mentioned, it's a way to dump any Python object and save it to our file system and then later on load it back. And it's a pipeline thing.
Very useful.
It's very useful, very, very useful.
So what's the purpose of taking a logarithm there?
Oh, in this particular case, if you remember, even in the earlier California housing, during the orchestration pipelines, we did it. So this is log transform is done when you feel that the data fits better with a logarithm, and we did it even in the orchestration pipeline. It is a way to it is based on analyzing the data. You sometimes feel that doing a logarithm of those fields gives a better fit.
Okay.
I mean, we could have tried it without logarithm. I have not, at this point, we have not explored that. Just take it
Chandra,
that we are
I'll
using.
speak to that. Yeah.
Yeah.
See, Albert, this goes to the Box-Cox transform. Remember that features, they are best handled by machine learning when they show more or less a normal distribution. If a feature doesn't exhibit a normal distribution, if it has a strong skew. So imagine, right, that some numbers, for example, Mac mansions are very, very expensive, right? Or a number of bedrooms, etc. Things like that. Whenever data shows a strong skew, you need to do a transform to make it more normalized. And one of the most common transforms that mostly does the job, and you can verify by doing it, is the log transform. Whenever you see skewed data, take a log transform, and it might make it much more normal distributed. That's the purpose of it.
Thank you.
So,
Okay.
picking up the question from Hemant, the joblib was basically storing data in our local file system, right?
Yes.
When we're doing inferencing real time, we don't need this step. There is something else being done at that time.
Sorry?
When you want to do a real time inference,
Yes.
do you go through the same process, or do you?
Yes. We will use it. We will use this saved model during the real-time inference.
Okay.
Because it has to go through the same. Otherwise, your input data, let us say during the real-time serving, you are passing in some data. You don't know which column to do a log transform of, which column to do a one-hot encoding of. You wouldn't know that, right? So you need to save it so that you are able to repeat that process for the incoming data during inference.
Okay. I got it.
Okay. Yeah. So that was the pre-process step here. So what I mainly want to cover here is Ray dataset supports all those typical pre-processing activities that one would want, like having a ability to create a custom preprocessor with a fit and transform and those kind of features. Okay, so then so that is the next three steps here: pre-process. One is passed with is true, and then others with is train as true and is train as false. And so finally we have these process data sets, and we are taking it to this random forest method. So this method it will take some time to walk through. So what are we doing here? So here we are using a search space. So this search space is you may recollect that we did something similar while doing either MLflow labs or during Comet and Neptune. We have this concept of a search space and through it will iterate through this possible n estimators, which are basically between some lower cutoff and upper cutoff, and likewise the n jobs. These are hyperparameters specific to the random forest. So it is doing a in this case it is doing a search space optimization, and I think it uses Bayesian optimization here. I am not. We have to check, because I think it uses Bayesian optimization to decide which is the best run. So it goes through the search space. So this tune is something which is again it is a ray construct. So if you see, this tune comes from um, it's a ray tune. So what it does is it takes in, if you look at the kind of parameters it takes a random forest trainable, which I have defined within this class. I will show it to you. This is it takes a search space, which I have defined here. And here I am saying that I try 20 iterations. I'm not trying more than that. And the resources per trial here, I'm not using GPU here. So I'm only going to use CPU at this point. So we could have changed this based on the whatever our ability in our local whatever VM that we are using. If we have more an ability to handle with more CPUs for each worker, we can give a higher number also. Okay. And what is the metric I am going to use to do the optimization, and whether it is a minimization or maximization. So these are the parameters that we define. So now, and in this case, there is a train iteration one. I'll come to that. Okay. So this basically says that I'm each time I'll go to this random forest trainable now, and this itself is inheriting from trainable, which is again available within the Ray framework. So trainable. So what are we doing here? This helps in doing a iteration through this. So we need to have this step function here, which is being overridden. So if you see this trainable has a step parameter, and this is what it returns for every particular choice of hyperparameter. It returns the MSC for that particular choice. So what have we done here? So while initializing it in the setup, we passed in the particular estimator and job that that came in that particular iteration. So what were these estimators and jobs? This estimator and job were one of these values that came from this search space. So this in n estimators and n jobs, we are going between 900 and 1500, 14 and 28. So let us say because we are doing 20 iterations, it has come to something like 1024, for example, because it has randomly chosen 1024. So in a particular step of this run, it would have gone to this random forest trainable and chosen that particular hyperparameter of n estimators and n jobs, which is 1024, and it would have initialized the random forest regressor with that particular value. And having initialized with that value of the random forest regressor, this step would actually fit the training data with that particular value of hyperparameter, and it is going to return the mean squared error, which is basically the validation error here. Because if you see, it is between the y prediction and y val. And what are these? These are coming from the validation data. So if you see, during the setup, we have passed in the training as well as the validation data set. The random forest regressor has been trained on the training data, and the MSE is calculated on the validation data. So in each step, we are returning the particular validation MSC with one particular choice of n estimators and n jobs. So this is what this flow is doing. You may have to go through it in a little bit more detail to understand, but basically it is each step is going to return a particular value of the MSC, and this tune.run will do 20 such runs, which are going to be 20 choices between the 900 and 1500 and 14 and 28. And for each choice, we are running it once. That is what it is saying. This training iteration is one, means for every choice we are running once. We could have done for every choice 5, which means for every choice it would do 5 times and get the best out of those 5 for a given choice. But we are not doing that. We are just, I mean, it's not really required because we are actually doing a fit on the full data. If you notice here, the fit is happening on the entire data set because it's a small data set. It is just having some, I think 14,000 rows or something. So we are doing on the entire data. And how is this data getting created? If you notice here, we are iterating through the full data and we are building the training list and validation list. So the entire data is getting populated in the X train and Y train. We are not training in batches here. And once we have fitted it, we are calculating the MSC. And this MSC is being, the minimum value is being considered as the best of these. So is this clear? If any questions, stop me, okay? Because this looks a little complicated, but actually it is a standard. Whenever you have a tune.run, you always have one particular function or a class which keeps getting repeated, and we have a metric on which we either minimize or maximize. And at the end of it, you have a the best config. So the analysis is what is getting output here. So we are saying that the best based on the minimization is the best config. So this is what this flow is doing. And if you notice, the same job lib we are using to save the best model. And again, we are saving it in the same path which we saved the preprocessor. So any questions so far? So that is all there is to this random forest code. There is some other parts which is just to print out the metrics on the test data, but that is not really used. It is more for us to analyze whether whatever we did on the training data is performing well also on the test data. Because if you remember, we split it into train, validation, and test. So this is the code of the random forest. So if you are clear on the code, we can now run it. Any questions?
So we have to run the ray main.py.
Yeah, all we need to do is we can use the Visual Studio itself to run it. Okay, let me run it.
Where exactly are we using ray here?
Oh, okay. Sorry, I'll stop it and show it to you. 1 second. Okay. So if you see in the ingest, we started the whole thing with ingest, right? So here we are using ray.data. So everything is with ray.
Got it. Got it.
Okay. So I'm not explicitly doing a ray.init. It automatically takes care. I could have done that, but it's not really required. I mean, when it sees that I am using ray, it actually does a ray.init in the beginning. So I have not explicitly done a ray.init. I could have done a ray.init here, but it's not required. It automatically handles it when it sees that I'm trying to pull a ray, a data using ray framework. It internally does if it finds that array has not been initialized, it initializes it with ray.init. Okay. Yeah. So let me run it once again. So ray.init is what actually initializes your cluster on your local VM. So if you see, I don't know if you're seeing my output here. Let me expand it a bit. Where was it? Yeah, here. As soon as I started it, it is started a local ray instance, view the dashboard in so-and-so. Okay, and it has started pulling the data, and then it is once it gives messages on what is happening at every stage. Okay, most of the stages get quickly finished. Okay, somewhere it has failed. Okay, why has it failed? This will process. Let me see why it has failed. I have not myself run it. Let me see the reason it has failed. Oh, I didn't create this. I should have created a subfolder. I think we need the subfolder, right, Ravi? When you ran it.
Yes. Model and preprocessor. These two are required.
Okay, sorry. That. So my mistake. I'll add that in the notes. So we not only need the folder called array results, which I created. We also need to have these subfolders. Models, right?
No, model.
Model and
preprocessor.
One word.
Processor. Yeah, one word. Yeah.
Okay.
Yeah, you can see the code also.
Yeah. So this is. I didn't run it yesterday actually, so it's been a while. Ravi had tested it. So yeah, so we need this. That is why it failed. Let me restart it again. Okay. I have restarted after creating those two folders.
What what folders you created? Sorry.
Under basically okay. If you go to the if you go to the LLMOps config, we needed one directory where our models and preprocessor will get stored. Okay, so I had created this directory, but I forgot to create the subfolders for model and preprocessor under it. So if you see right now, I have this folder which is array results, under which I have two folders, model and preprocessor. And one other folder gets generated automatically by our run. Okay, now it is running. It is iterating through the trainable. That is what takes the maximum time. The rest of the code runs in no time. It iterates through the different hyperparameters to come up with the best model. Any one of you has come to the stage where it is running fine?
Yes.
Okay. You created those subfolders, right?
Yes.
Okay. Okay, something else failed. It failed because some lock file it is. Okay, this is in. Let me. I think this is at the last step it has failed. Did it happen for you, Ravi? There is this last step. Let me go to it anyway.
No, we didn't get.
Okay. I think because we are both using the same machine, I think there may be some permission issue when you ran. Let me go and.
Yeah, possible.
Okay, let me go to the. Most of you may not have this issue because you are having your own machine. We share one machine, so we have sometimes these. Let me see which one it is. Array underscore lock files.
So do we need to create the preprocessor also, or just array results folder?
Sorry, one second. Let me. I think I can remove all of these. I can remove, right?
Yeah, if you do RM minus F, minus RF.
Yeah.
I have also closed my session. I was also logged in.
So none of you should have this issue, because we have this issue because different users are using the same machine. So we sometimes encounter these issues. So sorry, I will rerun it once again. Where was I? Let me go back here.
Main file. You are in the
I'm not.
file.
Okay,
Yeah.
I was wondering. Yeah. Okay, hopefully this time it will go through. Aditya, it finished for you?
Still running.
Still running, okay.
So Chandar, I'm getting the preprocessor folder error.
Preprocessor folder error.
And
And
so Ray results, Ray underscore.
Did you
results.
create that folder?
I just created a Ray underscore results folder under the home.
Yeah, and under that you created the subfolders, model and preprocessor.
No, I didn't.
No, that was also required, because even I realized I didn't have it. So I'll show you. If you go to the you need to have a subfolder called model, a subfolder called preprocessor. These two are expected in the code. What it does is, inside in the code, it saves it under this model subfolder, the model best model. Under the preprocess subfolder, it saves the preprocessor model.
Okay, so two folders in that, one model and one preprocessor, right?
Right. These two are required. Yes. Again. Oh man. Why is this failing again?
Chandra, run it with a sudo.
No,
Run
this
command
shouldn't
with a sudo
happen.
before that.
Yeah, maybe I will give that folder access. I think I have had this issue in the past, but I don't know why it is. I know why, because that folder itself is owned by DevOps, right? I will give it full write access.
Yeah.
Okay, this should work now.
Chandra, how long is this expected to run?
On my machine, it takes a couple of minutes.
Oh, really? Okay.
Yeah.
Sanjeev, it will take a long time on your machine. This machine is a server.
Okay.
It has 64 physical cores.
Yeah, it's going on since 6 minutes now.
Okay.
Yes. Hopefully, it will finish before you wake up.
So I have to stop it at some point.
No, don't.
No. I think we have run it on our local Windows also in the past. It's okay. It's not. It may take 5 to 10 minutes, but I think it finishes. Okay, it finished successfully. So now we should. So at this point, I have a model which is saved. So I should be able to see the saved model. If I go to my Here I have both the preprocessor and the model. So this will have this is the best model.joblib. So this is what I have saved it as. So this is what I am going to use during the racer. Okay, and the preprocessor was already saved during the preprocessor. So if you see, we saved two parts. We saved both the preprocessor for the data during the training, as well as the inference preprocessor. Why do we have two different? Because during the training, we are also doing a log transform of the target. Okay, during the training, and we are doing the fit of the training incoming data with the target, which also has been log transformed. But while during inference, of course, we don't have a target value. So that is why the only difference between the two preprocessors is that this one is also having the target value being log transformed. This one, the target value is unknown, so it's not there. So we are only doing a processing of the feature values, and using that we are going to do the prediction. This part is clear, right? Why we have two of these? It is also done in the code. If you look at the code, we have in the pre-processing. If I go back to the pre-processing code, we are having two different. Where was it? Yeah. So we are having a preprocessor which is during the training and a preprocessor during inference. The only thing skipped is the target column. Okay. So did it finish for anyone or not yet?
Don't know what. It says pending, all these.
Pending. Okay, but it didn't fail also.
No, I didn't see any failure.
Okay. Maybe anyone wants to show their screen, whoever is, if it is stuck, let's see if pending is I don't know. Is it waiting for something else? I'm not sure. It should have run, right? Is anything at all running?
It is running. If I go to the.
Can I share my screen?
Yeah, I can stop sharing and one of you can share. You can also look at the dashboard.
Yeah.
Yeah.
I'll share.
Okay, so this is the dashboard, right? That 7265. You found it in 7265?
Yeah, so this is running right now.
Okay.
It's 8265.
8265, sorry. Yeah.
And it's running.
Right. Okay.
Then I go here, it's all pending right now. It says running 3 out of 10 CPUs.
Okay.
Maybe I should have used more CPUs over here.
How many do you have? I mean, you have, okay, you have 3 out of 10. So that means you use three, is it? In
Yeah,
your
10 right now. So I'm assuming it's using 3. I did not.
no, did you specify anything that use 3 or something? Because there is an option. You didn't specify, it automatically picked 3, right?
No.
Okay. I don't know why it takes so long, because, okay, if you go up, is there anything which has, everything says pending. And the same thing, even Albert, you also said the same thing, right?
I have some errors, I think. I can share my screen. That'll help.
Yeah, I'll stop. I do not have any errors as such.
Okay, trial status is pending. Oh, you have some errors. No, this is probably a past error, right? When you were having, can you clear the screen? I mean, I don't know. Can you go down? Let's look at the error at the end. This is some Albert Ray results. No, this is, you restarted it, right? after that. I don't know, go all the way down. No, right now those errors are not there. Those were the errors from the previous runs, I think, whatever you're showing. If you see up, I don't think those are errors in the current run.
So is this all good? I mean,
yeah, keep going up. Let us see where those errors came. Those errors came in the previous run, whatever you're.
I'll just wait then.
But in your case also, it is all showing pending. I don't know why it is taking so long.
Should I kill it and restart, or it'll...
No, don't. I mean, I am not.
Yeah.
Can you go to the dashboard? Can you go to your and confirm that everything is? You go to the 8265 localhost 8265.
Yeah, I see the same output as Albert.
You also see the same output. Okay. I don't know if there is a. Team, any of you in our team, Ravi or Akshaya, have you tried it on your Windows?
No, Windows we didn't try. We tried on
Yeah,
desktop
no.
only.
Okay.
Maybe we can try now. Let me check it.
I have tried it in the past. It has
Finished for
worked.
me.
Is this the dashboard, Sandra?
Yes, this is the dashboard. You can view all jobs here. Yeah, it is saying it is running.
It finished for me.
Oh, it finished. Okay, thank good. Okay, show me your screen then. I think it's just checking. It is probably the. I mean, I am working on probably a very powerful system, so it is running so fast.
No, Albert's system was also fast, I think. 32 CPU.
Mine is
Yeah. Strange. Yeah, so it has completed it. Oh, it is still saying pending though. This is Aditya?
Yeah, but it exited from there.
No, it doesn't seem to have finished it. It has just.
You can see in the folder whether
it's still running.
model is saved or not.
Just refresh the screen. No, it's not running.
I think it. Let me go to the folders which we created.
I think it has not finished. It has failed. Probably it didn't have enough memory.
Oh, that is. Oh, I see.
Yeah, but that is only the preprocessor which runs first. The random
Check the
forest
model.
runs later. So can you do one thing just for I have a, let's see if we can give additional resources in the code. Where to give it, I'll see.
So are we using the GPU here?
No, this is using CPU only.
Oh. So there's no advantage for me then.
But you still have enough CPUs, right? So I don't know if your. Let me see if you can give CPUs. Let me see if you can give higher number of CPUs and how many CPUs do you have on your local?
I think 10 please.
How many do you have?
10 cores, he's saying.
10. Okay. So try doing this. There is if you the tune.run, right? Tune.run. There is a parameter called resources per trial. Increase the CPU. I have by default I had given 2 there. Give a higher number. See if that helps. Do you see that? Maybe I'm not seeing your screen. In the tune.run, yeah, there's a resources per trial.
134.
That, yeah, give a higher number there. And also, just for current purposes, you can that num samples, no, just make it 2 in line number 133. Just let it run twice. I mean, I know it's not a great idea, but let us just run it twice. Everything else fine, and try to rerun it and see if it helps.
Do I need to delete the older files?
No,
No.
you don't need to. You just save this and run the main again.
Okay.
Have you saved it?
Yes.
So
Okay.
what did you change? What need to change?
I mean, I'm just trying this resources per trial. I'm giving higher CPU to it, so that it takes more CPUs for each run. And I have also decreased the number of trials to just 2. Has it progressed beyond the earlier, or you don't know yet? Okay, let it run. Let us see.
It's terminated now.
Nice.
I think it has done. Oh, it has done it. Go down all the way to the bottom. I think it has finished it. Yes, it has done it.
Yes.
Okay. Maybe Albert, you also try that giving higher CPUs.
Where do I do that? Sorry.
In the tune.run.
Best model that you got with the R squared of 83, it's about as high as it will go.
So raytune random forest.py. Is that the one?
Exactly. In that, go to the raytune random forest. Go to line number 134.
Yeah, that's true. It's a simple problem.
Okay. CPUs are 2, so
Increase it, because in my case with 2 it worked fine, but I think some of your machines it's not enough. I think you give more. I think how many cores do you have on your machine? You can give, like Aditya gave 6.
I'll give 8.
Okay.
And then restart everything, kill everything.
And I also, for him, just to because I didn't want it to run for a long time, the line number 133, make it to a smaller number. I have by default given 20. Try with just something like 2 or 3, just so that it just to prove the point that it is going to try over that many different combinations.
Okay. And should I stop it and rerun it again?
Yes. Stop whatever is already running. And having saved this updated one, you rerun the array main.
Just kill it, right?
Yeah, you can, whatever is running, you can kill it. Control C. So I have started sharing my screen again. So what I was suggesting is this line number to make a higher value, and this one to make a smaller value, because I think it is taking too long otherwise. Somewhere. And Albert, did you do it?
Yes, it's running so fast.
Okay.
Not finished yet, but it's done. Yeah, it's done within less than a minute.
Oh, it finished, is it? Albert?
Yes, it finished. It already finished. So
And it gave the result also, the best model and all that? In the terminal, I mean.
Yes, it says no configuration file specified.
Maybe you can share your screen. Otherwise, I don't know what you're.
Can you see the screen?
Yeah, go all the way to the bottom of your terminal. Yeah, it has created it. It is succeeded. Finish generation, it says, no? It says finish generation of the random forest model. So it is done. It has created the best model. And if you go down to your Ray results, you will find that it is also saved the joblib file there. If you go to the Ray results on your local. No, the Ray results. I mean, the Ray results. You created a directory called Ray results, right, in your terminal. Yeah, under the model, go under the model, you will find that there is a best model. Yes, it has created it. Okay, so you don't have to open it. Okay, so now we are ready to go to the second part, which is serving this model to validate that it works fine. So I think, am I sharing? No, I'm not sharing. Let me start sharing. So the second part is actually very simple to serve it. So maybe what we will do, we will only cover the lab 1 today. And because we can cover the lab 2 in the Thursday class, which is going to use MLflow to do the same thing. And the only difference between what we are going to do now and what we will do with MLflow is we are going to follow the best practice of using a model registry instead of saving it in a local file path. And for that, we will use MLflow's inbuilt model registry. So that we will cover on Thursday. It shouldn't take too long. And then we will go on to the more complex example on Thursday. But today, we will complete it with using RayServe to serve the application. Okay, fine.
So do we need the MariaDB? Because last time
you don't need. If you see, none of this code required any of the database because we are doing everything in memory itself here. Because Ray has we are handling everything in as a distributed data. So we are doing Ray data and we are handling it in memory. We are doing the ingestion, pre-processing, and creating the model. Everything we are doing in memory. And finally, we are saving the model in a file system, and we are going to use that model to do the RayServe.
Okay, thank you.
Okay, so the second part of it is basically we will go to the RayServe.py, which is located in the same folder. So here there is a RayServe.py, and again there is a lot of boilerplate code here. Which if you look at RayServe documentation in the ray.io, you will find that pretty much they follow the same pattern. So you have this annotation serve.deployment, which is what says that what is it that needs to serve, and it has to it has to override a call method. So what happens is when the serve.start is happening, it will end up opening up this particular method for the incoming REST requests. Okay, so this is the way typical RayServe code looks like. And what we are doing here is this bind is going to end up using these arguments. It will pass to the init. So this is what ends up acting as the constructor for this class. So when you do bind and pass parameters, those parameters get passed to the init constructor of the particular class. So in this case, if you see, model ref and preprocessor are what are being bound to the random forest model class. So when it is instantiated, you are ending up creating a deployment which is instantiated with this particular model and preprocessor. So what are these model and preprocessor? So if you look at the code here, we are picking what we are doing in the beginning is using the config file to pick up the particular best model path and preprocessor path. So this is what we are doing. And we are loading the best model. Now, there is one particular point here. This model itself is a fairly large object. So we should not directly use the model. We should instead put it into the distributed memory, which is why we are doing ray.put. So we are creating a distributed reference to this model, and this is what is being used. Likewise, the preprocessor, we are actually directly loading it. So in this case, only for the model, because the model is large, the random forest model, we are not directly putting it into the object. So this is a small subtlety here. What we are doing is we are using the distributed memory to save the model ref, and using that model ref to get back the model in every deployment. Because what can happen is when you're serving it in a uh, uh, when you're doing model.serve, in principle you can serve it across multiple nodes. Okay, in this case we are not doing those annotations. I will show you what are those annotations later on. We can put annotations here to say that we are going to serve it over this many different nodes, but right now we are not doing all that. We are just serving by using the default option where it is just going to serve in one place. But when we are serving across multiple nodes, you don't want to load the model in each node directly. You want to go through the distributed memory, which is the one point which is done here, because otherwise actually it fails. I mean, you can try it out without doing this ray.put and ray.get. You will encounter errors because it will say there is you're not having enough memory to load it into that instance. Okay, so that is what the init is doing right now. And finally, we are going to do a serve.run, which opens up this particular port, and it opens up this path for this call to get handled. So this call itself is pretty simple. What we are doing is we are going to pass in a JSON object in a post request, and that JSON will basically be the JSON which contains the California housing data. So I have shown it in the, so this will be the, because we know that this is just a random values I have given, which are falling within the range, but the JSON object will contain those columns which are part of the California housing data set. So we are passing in this prediction request. So if you look at the code, it is first of all getting the data, and it is creating a list of data, because once we have a list, we can construct a data set out of it. Okay, so this is a normal list. This is a list of JSON objects, and from those JSON objects, that list we are creating a data set, which is a array data set. And if you see the array data set, we are converting it into pandas here. So we are first doing a transformation using the preprocessor, and then we are converting it into the pandas, because ultimately the model that we have saved was using a pandas data frame. So this is the flow that we have in the prediction. Okay, so is that all clear, this code?
Yes.
Okay, let's run it now, and we will confirm that it is working fine. So you can also run it locally. At some point, it should say that it is serving on a I think now it should.
I think
Ravi,
it does
when
not
you
say it. It does
Does
not
it say?
it.
It doesn't say it.
No,
No?
no.
Okay, it is already ready. Okay, because
Deployed
in
app
fast.
used to default, I think, last
Okay,
time.
fine. Okay, the fact that it is deployed means we should be able to access it. So now we have this on this port on this 8082 at local host. This predict should return values. So let us validate it. And I have a curl command which I can copy over. So this is basically localhost 8080. And with the JSON, which is having the columns that my California housing dataset had. So I will run it on my okay. This is a curl command. Okay, so it gave a prediction. So this is the value that the prediction gave. I can change some things and see whether it is changing. So let me go to the
total bedrooms 300.
I just picked some random similar kind of rows which were there in the California housing dataset.
Population 600.
These were there in the. I mean, I looked at the typical values that were there in the California housing dataset.
And what's the price it came out with?
It came out with this. This is the value 337.
For 1990, it's very reasonable prediction.
Yeah, let me give, instead of nearby, I will give, I think, one of the other options. Anyone offhand recollects other than nearby? Let me see it.
Inland.
I will. Inland, is that the correct word? Inland?
Inland, I think it is.
Okay, and it should be lower because usually bay is more expensive, right? We'll confirm that it is. Yeah, it is lower.
Yeah, there we go. Nice, it's working.
So, yeah. So, I mean, it's a very simple example, of course, but it kind of walks through the whole flow of Ray data, using Ray data to do an ingestion, pre-processing, tuning. We have not covered training so far, tuning, and finally serving the model. And in the process, a nuance about the fact that if you have a large sized object, better to put it in a distributed memory and retrieve it from distributed memory. If you don't do that, it actually fails. I mean, you can try it. Just like the preprocessor has been directly put here in the constructor, if you try the same thing with the best model, very likely it will fail. You can try it.
So Chandra, a question. So 8082/predict, right? That's where you should see.
Yes. Because that is what I have defined here. I have put 8082 and I have put predict as the path where you should look for it.
Okay. What if you don't get anything? Here's errors on the screen.
It should not. You are getting errors?
I don't get any errors deploying the app, but then after that, when I go to the URL,
okay,
does not.
maybe you should share your screen. Let us see.
Yeah, I get the same thing, the error, but I think it's because we are not posting a request. Exactly the same thing.
Oh, no. You went to the URL. No. This is you have to go to you have to do a curl command. I shared one curl command, no?
Okay.
Okay.
Or you
Because
can use Postman.
yeah, you can use Postman if you want, but then you need to have Postman installed and all that. But a curl command usually is good enough to validate your service.
Where's the curl command?
It is on that. Okay, am I not sharing? Okay, I stopped sharing. Okay, can I start sharing?
Yes, let me. Yeah.
So in the MK docs, I gave a curl command.
Okay.
And you can play around. You can change this to some other value, and you cannot change the longitude, latitude too much because that is where California is. We cannot change it too much. We can make sure, otherwise you may be in the ocean or somewhere. But these other numbers for sure you can change quite a bit. So what we will cover on Wednesday night, we will complete this exercise by using MLflow, which will kind of integrate with what we have learned a couple of weeks ago on MLflow also. Okay, and we will use MLflow mainly as a model registry right now in this next lab.
So you should get some prediction, correct? That's all, right?
Yes, that is all.
Some value, okay, got that. Thank you.
Everyone able to get it? Aditya, you were able to get it? Okay.
Yes.
Sanjeev?
Yeah, I'm running that curl command.
Okay.
Yeah, I got a prediction. Yeah, I did.
Okay. Yeah, so that covers the simple lab. I think we are done for the day. I think we can proceed with the MLflow part of it on maybe the first part of the next lab session, and then we will do a more complex example in the second part.
Nice. Chandra, thanks for this nice walkthrough.
Oh, thank you. Yeah, I mean, some of these things, as you keep doing, only you realize, like, for example, this number of resources, the best way to learn is by actually doing it, because by looking at what somebody else has done, we invariably we think we have got it right, but when we run it, we encounter issues.
Right. Nice. Any questions, Albert, Sanjeev?
I just played with some of the parameters over there. So from bedrooms from 300 to 3 and 1, I could get exactly the same prediction for 3 bedrooms and 1 bedroom.
Then the location must be the factor there.
I did not change it.
Can you show?
Yeah.
See, in real estate, they say, right, there are 3 factors that matter.
Location.
Yeah. If you don't change the location, you just validate the point that. So if you share your screen, Chandra is asking.
Yeah. What did you change in the previous and current? Total rooms. No, I think total rooms is that one is not a typical value at all. I'll tell you the typical value. The typical value that you find is much larger.
Yeah, 100. Because it's a whole block, right? You cannot have a block with just 1 bedroom.
Actually, why don't you have that MariaDB, right? Installed. You can actually go and look at some typical rows of the California housing data set if you have the MariaDB with you. If not, I can pull it up. So make sure, yeah, you have it. So you go to the California housing, not the processed one, the original data, which is there in the not the processed one, not the feature store. If you go to the MLOps data store, yeah, go to that and open the original data and look at a typical row. Show data. You can go to view data. Data, the second tab, yes. Yeah, pick values which are somewhat in that range that you find here. Okay, so if you see the total rooms is of the order of hundreds or even thousands. So 1 is actually not at all in range, right?
Yeah, I think as for my data, I just made the 1 bedroom house the only house in the whole street.
No, this data set, I mean, we need to understand this. This data set, when they say total bedrooms, total rooms, I think they are referring to, like Asif said, the total in a particular location or something. It is not within a given house.
It's a block.
Yeah.
The data is at the level of a
No, what I was saying is I kind of made that the house was the only house in the whole block.
Oh, yes.
Yeah. Right. So give a data which is more in line with the typical data in this, and I think the prediction should be I have checked it. The prediction is very good because California housing is a well-studied problem, right? So you get good results.
Yeah. No, definitely. I was not aware of what it meant exactly earlier, so I just played around. Maybe when I'm buying a house, I'll use this to predict the table for the house.
Yeah, except that adjust for the cost of the average cost ratio. It is about 3 times now.
I think we can stop the recording.